For this next lesson, we're going to look at natural logarithms. Now, natural logarithms are very similar to normal logarithms. The difference is in what the base is going to be. We've talked a little bit already about a base e, or e to the x, being the natural exponent. Now, if we want to take the log of a base e, then instead of writing log base e, we can write ln. You can see that ln is the exact same thing as log base e, so you can treat it the exact same way. And if you ever get confused on working out a problem and you're not exactly sure what you're supposed to do next, go ahead and change it to a log base e, because that's probably going to lead you to, say, changing it to exponential form, which is going to allow you to get to the correct answer. So let's look at problem number 1. We're given 2 ln of 15 minus ln of 75. So all of the same rules that we used for combining logarithms apply here. We're going to take this 2 and we're going to move it to the exponent spot on the 15. So now we've got ln of 15 squared minus ln of 75. Now let's go ahead and simplify that 15 squared. 15 squared is going to be 225. So we get ln of 225 minus ln of 75. Now all we have to do is remember our properties of logarithms. Whenever we're subtracting two logarithms, remember that we're going to take whatever is in the x spot and we're going to divide those things. So here we're going to have ln 225 divided by 75. Now the last thing that you want to do here is to go ahead and simplify if possible. 75 does go into 225 3 times, so we end up with ln of 3. And that's how you're going to solve, or that's how you're going to combine two natural logarithms into one. Now to solve problem number 2, I want to take you back to something that we did earlier in the course, which was solving a quadratic equation that cannot be factored. One of the methods that you learned was to complete the square. And so what we did was we moved the 8 over and we said x squared plus 6x, and we left ourselves a blank spot here to be able to complete the square. And then we said that's equal to 8. Then we divided the 6 by 2, and then we squared that result. So we would end up with plus 9. Then you add 9 to this side. What would end up happening is you could now take this, which is a perfect square trinomial, and you could factor that down to x plus 3 squared. And then over here on the other side, you would have 17. Now remember, what you could do was, you could, in order to get rid of that square, you could take the square root of both sides. And so when we took the square root of both sides, we ended up with x plus 3 is equal to plus or minus the square root of 17. And then to solve for x, all we had to do was move that 3 over to the other side, and we ended up with x equals negative 3 plus or minus the square root of 17. Now to solve the next problem, we're going to do something very similar to that. We're going to end up using this idea of taking the square root to get rid of that square on a factor to solve this problem. So in problem number 2, we've got ln of x minus 3 squared equals 4. So again, if you forget that ln is log base e, just go ahead and change that. Or if you don't understand how to do this, go ahead and change it to log base e, and that might make it a little bit easier for you to work this out. So log base e of x minus 3 squared equals 4. So now what we've got, we see that we've got our base, we've got our y value, and then this entire thing, that entire factor right there, that's going to be our x value. So we can go e to the 4th is equal to x minus 3 squared. Now, rather than going ahead and foiling this out and trying to solve it like that and getting really complicated with it, let's just try and get rid of that square by taking the square root. So we take the square root of both sides. Now, when you take the square root of e to the 4th, it's just like taking the square root of x to the 4th. It's just going to give you x squared, in this case, e squared. Since we're taking the square root in an equation, we're going to go plus or minus e squared is equal to x minus 3. Now all we've got to do is to move that negative 3 over by adding 3 to both sides, and we're going to get x is equal to 3 plus or minus e squared. And that's how you're going to solve that problem. Okay, for problem number 3, we're going to take a look at a problem that would not necessarily be an issue if we didn't have e here with an e to the x. We'll take a look at how how we can solve this fairly easily without too much trouble. What you want to do here is you want to isolate the e first. Okay, so to isolate the e, we're going to do just like we would with any other equation. And we're going to work the opposite of the order of operations. So we're going to start with addition and subtraction, and then move to multiplication and division, and then we're going to get rid of that exponent. So the first thing we're going to do is subtract 2 from both sides. So we get 4e to the 2x is equal to 14. The next thing we're going to do is we're going to divide that 4 out so that we get e to the 2x is equal to 14 over 4. Now at this point, I would actually go ahead and convert this to a decimal because we don't want to have, we might end up with a complex fraction, and we really don't want to deal with complex fractions when we're working with logarithms. So 14 over 4 is the same thing as saying 7 over 2, which is going to convert to 3.5. So I'm going to rewrite this as e to the 2x equals 3.5. Now you notice that what we have here is a base, an exponent, and what it's equal to. So we have something in the form of b to the y equals x. So we can change b to the y equals x into a logarithm. And remember that that would be log base b of x is equal to y. So let's go ahead and change this to log base e of 3.5 equals 2x. Now, what we can do here is we're looking to isolate that x again. So the 2 is multiplying into the x, so now we can just divide out the 2. When we do that, we're going to get log base e of 3.5 over 2 is equal to x. The final step would be if you want to go this route and call it log base e, you're just going to convert back to the natural logarithm at the end. And we're going to say this is ln of 3.5 over 2 is equal to x, just so that we can get it into the right format. And that's how you're going to go from this seemingly difficult equation down to a solution. Now, the last thing here is that you could go ahead and convert this over to a decimal. Remember that this is going to be your most accurate answer because this is not an approximation, this is the actual answer. If you're asked for an approximation, go ahead and plug that into your calculator and you're going to end up with 0.626 being your approximation. So you may be asked for the actual answer or you may be asked for an approximate answer. Make sure that you know how to do both.